Hi, I'd like to welcome everybody to our webinar today regarding Sd-Wan. My name is Kevin Poe. I'm your networking systems engineer for Citrix Systems, and I would like to thank Accudata for facilitating this webinar today. So let's kick this thing off with going into what Sd-Wan is and what we feel Sd-Wan is as far as Citrix is concerned. So Sd-Wan is a very new term. It is something that within the last year has gained a lot of traction, and there isn't really an industry standard as to what SD-WAN actually is. But I can tell you what we at Citrix believe SD-WAN to be. We believe it to be an evolution of what we have been doing in this particular sector for quite a while, which is optimizing the WAN and giving customers of ours the ability to have good application performance, right, and best user experience. But what we found is that classic WAN optimization that's been around for many, many years, we've been in that business for a long, long time, and there's a lot of competitors in that space as well, that is no longer viable compared to what it was years ago. Because years ago, we had very restrictive WAN connections. Restrictive WAN connections that were perhaps 1.5 megabits per second, where we needed to squeeze as much data through these pipes as possible. But these days, bandwidth is abundant, right? And we still have resiliency issues. So what we found is that with that being the case, we need to do something a little bit differently, right? More than just optimizing the WAN, more than just compression, more than just deduplication and reducing the effective latency. What we found is that perhaps what we can do is something called WAN virtualization, where we take multiple WAN links and combine them together to have them behave as one to improve resiliency and et cetera. And that's what we see as SD-WAN, right? Being able to combine the benefits of WAN virtualization and WAN optimization to yield even greater user experience. And with that, what we've seen is that when we increase resiliency by aggregating multiple links together, we've seen that we're able to reduce cost, we're able to keep reliability up for a particular branch, and now, of course, at the same time, because we're massaging that traffic, we're also able to increase user experience and potentially reduce the hardware footprint at a particular branch, and of course, centralize management and control. And I'll go into what each of these really mean in a little bit here. But the gist of it is that we're looking at something called, at Citrix, called virtual WAN. That being the ability, again, right, to aggregate multiple links together. And you may potentially think that this is classic link load balancing, but this is actually not the case. What we're actually looking at here is the ability to aggregate on a per packet level basis, meaning that on a per packet level basis, we are making decisions as to which line to choose. And because we're doing that, what we're able to do is we're actually able to use all the bandwidth at once. So if, take for example here, in my example that we have a internet connection, whether it's DSL or cable, combined with MPLS and 4G LTE, let's say we're talking about 10 megs of cable plus 10 megs of MPLS plus 10 megs of 4G LTE. This is actually 30 megs of throughput that we can now tap into, right? Whereas classically, this would be something that'd be active, passive, potentially, where you would only fail over, right, if a particular link is not working. So now we have full access to all this bandwidth. And also, because we are actively measuring the health of each of these connections, we can dynamically select which is the best link to use. So that means if a particular link is not behaving properly, right, we can shift that traffic immediately to another link. So this is how you can start seeing how we're building that picture of resiliency. And because we are reacting so quickly, all of a sudden, that also means that SLAs that are usually associated with particular WAN link types aren't necessarily as important, because we see a lot of customers pay a lot of money for MPLS connectivity because SLAs, right, is what's important. You're paying those high dollars for that resiliency. But if we're talking about being able to react quickly to network and line condition changes, right, what you're able to do is now you're able to combine not as reliable links together to have even greater resiliency. So, and I have a diagram in a little bit here to show you guys that. So you can see here that in my particular example here, we have a MPLS link that is pushing approximately 4 megs per second, and we have a broadband internet connection. Sorry, let me reverse that. We have a broadband internet connection that's pushing 4 megs per second, and a 1.5 meg T1, right? And we're running a particular TCP flow, whether it's CIFS, FTP, or et cetera, right? We are actually consuming all the bandwidth, right? Therefore, we are aggregating 5 megs of throughput. So that's a very, very easy and cheap way to grow your bandwidth. But talking about cost savings, right, and achieving a particular SLA that you're interested in, what we can see that we can do here is we can actually mathematically calculate what SLAs that you will achieve, right? Again, because we are reacting so quickly to these line condition changes, we're essentially doing risk mitigation. The more we add together, the more we aggregate together. So we can take something like an MPLS class line that would normally yield approximately an hour of downtime. So 1 hour downtime doesn't necessarily mean, for the entire 1 hour duration. You're looking at a complete line outage, but that within that 1 month of 1 hour outage, you're looking at approximately 1 hour of them exceeding whatever SLAs are promising you, right? So if we can very quickly switch between these links, what we can do is we can start mathematically calculating these SLAs together. So if we take, for example, business class DSL, right, which has approximately 7 hours of downtime per month, right, plus business class cable, right, let's say, which has 15 hours of outage, right, we can see that we can mathematically calculate that out to be 99.95% available, which is higher, right, than a single MPLS line. And the reason why we're able to do that is because of this real-time measurement, right? And because of this real-time measurement, we're able to do per packet-based selection. And we're also able to do something called bidirectional measurements as well, where in this particular example, you're seeing 3 paths from A to B, but that's actually 6 paths because ingress and egress is counted as a separate path. So just because a particular packet from A to B may be most resilient on MPLS doesn't necessarily mean the return path is resilient on MPLS. Maybe the return path at that given moment, right, the fastest is going through your broadband DSL connection, right? We can make that decision. So a really good analogy that I like to use is that this is very similar to what VMware did for our server infrastructure, right? Where back in the day, a Exchange server was a very specific type of server where it had a very specific configuration, right? Whether it's a memory configuration, the type of memory, the amount of memory, what CPUs you guys had, what the RAID configuration was, what disks were in that particular box. But with the hypervisor, right, now Exchange server is simply a VM. So which server does it reside on, right? With their HA technology and DRS technology, that VM could reside anywhere because it's ever moving back and forth between different hosts, right? And we are looking to do with SD-WAN, the same thing, but for the WAN, where which WAN connection is that packet going to go on? We don't know, but whichever is the healthiest is what we're going to choose. So another really cool thing that SD-WAN can do is that we can start doing some really interesting things, like especially when we're doing this per packet level aggregation, is that we can start doing things like packet duplication, where we can repeat packets that are particularly important to you guys, whether it's, for example, very loss-sensitive traffic like voice over IP, or perhaps video conferencing, or perhaps even running VDI workloads through your WAN, where loss will affect user experience. We can actually duplicate those packets, meaning that we will actually repeat those packets through as many WAN links as you choose as the administrator, and the first packet that arrives is the one we keep. And that actually makes it very, very interesting because voice over IP is something that is very loss sensitive, right? It is built on UDP, and UDP is inherently unreliable. But with SD-WAN technology, what we're able to do is we're able to encapsulate that UDP packet, right? Repeat it multiple times, right? To ensure that it gets to the destination. So we're inherently making something so that is unreliable, reliable, right? By design, unreliable, reliable. So that is very, very, very compelling. So you can start seeing, right? Why we're talking about branch resiliency, why we're talking about improved application experience, right? That can be yielded with something like SD-WAN. And finally, what makes this really all this possible is that we adapt to line condition changes on a sub-second level. So we're actually talking about fractions of a millisecond. And in fact, we've done some demonstrations here locally that we've had these appliances set up where we have multiple, mock WAN links set up, and we have audience members come up to cut lines while there's a TCP session like a voice conversation going, to show that because of this sub-second level adaptation, right, we're actually able to react very quickly and actually not drop any packets and continue the voice conversations, right, from branch to data center or branch to branch. And that kind of takes me to this next component here, is that it kind of does away with the traditional hub and spoke type deployment, right? You guys are doing point-to-points or perhaps MPLS with different vendors and et cetera, is that, if there is a path from A to B, we can actually create a full mesh network as well. So whether it's phone conversations from branch to branch or any other kind of branch-to-branch communication, right? We will facilitate that as well, because we can, through this SD-WAN mechanism, right, create a WAN cloud, if you will, a private cloud. And another really nice perk as well is that what we can actually do is we can actually pipe out internet traffic from the branch as well. So you don't have to backhaul all that internet traffic back to the data center, right? It's because there's already an internet connection at the branch, right? Why would SD-WAN not allow you to pipe that out? And one thing that Citrix in particular is doing is not only are we piping that traffic out, but you also have the option of running that traffic through a secure web gateway, right? Like Zscaler and et cetera, so you can do the IPS and continue to do the content filtering, right? Without having to run it all through the data center, to run it through the IPS system within the data center. And, with the ability to measure these WAN links' health in real time, right, we're also able to record and historically record this information as well. And with this information, we found that what SD-WAN enables our customers to do is actually take these reports, because we now know what latency is like at any given moment for let's say, for the past month, right? Latency and jitter and losses like for a particular line. What our customers are able to do now with SD-WAN is actually take these reports and take them back to the telco company, right, and hold them accountable for whatever SLAs that they're promising you, right? Especially when you're paying high dollar amounts for MPLS. Currently, there just isn't that kind of tool out there that would give you real-time and historical information. But with SD-WAN, because we're doing these measurements constantly, right, you're able to hold your telco companies accountable and have actions taken upon when you bring them up. So that kind of brings me to like a summary of what I've been talking about, right? Is what does SD-WAN do? SD-WAN gives you guys true bonding, meaning that we are increasing bandwidth because we are doing active type of packet level aggregation, right? A particular TCP flow will use all the bandwidth available. So a very good way to increase bandwidth, right, without having to pay big bucks to increase your MPLS lines by augmenting it with cheaper broadband. And by improving, ultimately, right, your end user experience, packet duplication for any kind of a loss-sensitive traffic types, like I mentioned, voice traffic or video conference traffic or any other type of traffic where user experience is very, very important. And also being able to stack on legacy technology, like our WAN optimization technology, to reduce the effects of latency where you need it, right? Because if you have branch offices, let's say in India or South Africa, where latency is not something that you can necessarily conquer, but you can, of course, add resiliency with this multi-link aggregation that we're talking about here. You still need something to handle that latency, right, and do that caching and do that duplication. We can actually stack those technologies together with WAN optimization. And ultimately, right, to provide highly resilient branch offices by eliminating downtime. Real-time adaptations, right? Not just the blackouts, right? Anybody can react when a particular line is down. I mean, we have that available today with, BGP and other routing protocols being detect bad routes and fail over to a secondary route, right? But what we're talking about here is not just reacting to blackouts, but also reacting to brownouts, right? And brownouts is what really affects your application experience, right? And spikes in latency, spikes in jitter, right? Sudden increase in loss, right, is what gives those voice conversations, for example, through voice over IP, right? That bad quality, right? That bad sound, right? Being able to react quickly to those and shift traffic to another WAN link. And another really interesting perk is I was drawing parallels to what VMware did for or virtualization in general has done for our industry, but being able to virtualize the WAN as well with SD-WAN, right, also now means that you don't have to take any outages during maintenance, because should you decide that a particular WAN link needs to go down, right, because you have multiple WAN links that you're riding on, and because we're reacting again very quickly to brownout or blackout situations, you can actually have a WAN link completely go down, right, yet traffic continues to flow and the packet doesn't get dropped. And with that comes another perk as well, is that you're no longer bound to a particular provider, right? The particular provider is not treating you well, or you're not satisfied with the customer support that you're receiving from them, right? Now you're not bound to that, because moving from MPLS provider to DSL provider, or DSL provider to cable provider, or anything essentially that's an Ethernet handoff, as far as Citrix is concerned, right, is very, very easy. And not just is it easy for you as the organization, right, or the administrative organization, but it's also easy for your user base as well, because your user base will not notice that outage. And most important of all, and most compelling of all, is definitely being able to reduce your WAN spend, right? Because a T1 MPLS connection these days probably averages around $400 or $500 per month, right? If you're looking at 1.5 megs of throughput. But if you're looking at potentially taking a 10 meg MPLS connection and augmenting it with another 10 meg DSL connection, right, or a cable connection, where you're looking at 20, 30 megs of throughput, right, nearly 30 times the throughput that you had before at a fraction of the cost. So, this is all definitely something that is worth taking note. These are special because they're the enterprise edition, right? So these are the ones that not only can do this packet level aggregation with virtual WAN, right, but can also at the same time, right, leverage our legacy WAN op functionality, right? So these are probably for those offshore sites where not only do we want to aggregate multiple links together to provide resiliency, but we also want to optimize the traffic that flows through there, right, to get the best user experience possible when there's latency and other things that we can't control. So I think that just about wraps up what I had to present today. I just wanted to thank Accudata again for facilitating this recording. And my name is Kevin Poe, again with Citrix Systems, your NetScaler systems engineer. Thank you.